My name is Steve Schmidt. I'm the Chief Information Security Officer for Amazon Web Services, and wanted to have a brief discussion with you here today about security and compliance in the AWS environment. I'd like to make this relatively interactive, so we're going to go through a whole bunch of stuff in the beginning here that'll give you a grounding in what AWS is and does from a security perspective. But we'll also have a lot of time for Q&A at the end because I think that's pretty beneficial for folks. Just to make sure we're all on the same page here, we're talking about the security of our platform as a whole and your infrastructure that runs on our platform, which means we pay a lot of attention to how the bits and pieces fit together. And a lot of the conversation we're going to have is about how we ensure that we don't have anything fall through the cracks between those different bits and pieces. The slide you got on the screen here is something you've probably seen before at one of our presentations. Gives you an idea of all the different pieces that make up our infrastructure. The primary focus of our conversation, however, is going to be this, which is our security model. This one's a real eye chart, but we'll go into each individual piece as we have a conversation today. The important part here is the upper right-hand corner, which is a shared responsibility model. AWS is responsible for a large portion of the security of our platform, but neither of us, neither the customer nor AWS, can be successful without the entirety of our environment being secure and the customer's infrastructure running atop it. So we're going to talk a little bit about our networks, virtual machines, the management plane, administrative access, physical security, and how we express that to our customers, which is the certification and accreditation process. The shared responsibility model divides what we do into two major pieces, that which is AWS's responsibility, our job, and the customer's responsibility on top of that. The important thing for us to convey here is where that dividing line is. You can't be successful unless we clearly define what you need to do in order to make yourselves secure on our infrastructure, and at the same time identify for you what we do to make your job easier. So we'll talk a little bit about the physical facilities, the security of them, the infrastructure that goes with them, how we protect our networks that your traffic rides on, and the virtualization infrastructure that underpins all of the different pieces of our EC2 environment especially. Lots of people have questions about how we do this. There's a lot of detail that you'd like to get into, I understand that. So we've got a security website right off of the AWS homepage that I encourage you to take a look at. We've got a security white paper there that goes into great detail on the controls that are present in our environment, how we evaluate the sufficiency of those controls, both internally and using external auditors, as well as some risk and compliance paper for those who are interested in dealing with specific verticals. So whether you've got a healthcare application running on our platform, a financial application, credit card processing, or anything else that involves PII, as an example there. An important thing, security is not a static object. It's something that moves quite fluidly as our platform evolves. So I encourage you to frequently check back with the Security Center to make sure you're using the latest version of our documentation. The documentation includes the risk and compliance white paper, security white paper, but also a series of best practice documents. The best practices will help you go through, evaluate your own instantiation of the AWS environment, and ensure you're doing those things that we and others have found to be the most effective in protecting your infrastructure and your information. The last bullet on here is personally very important to me. If you find something that's beneficial to you, we'd love to hear about it. If you find something that you think could use some work, some improvement, or areas where you'd like some more explanation, please do let us know. This is something that we've focused a lot of time and effort on, and we'd love to hear more back from you about it. Certification process, and I use the term certification here a little bit loosely because there are certainly industry standard certifications like ISO 27001 that we're going to talk about, but there are also audit processes that many people colloquially call certifications. We're going to go through several of the major ones here. Sarbanes-Oxley is obviously important to anybody who runs on a large infrastructure, who runs a large business on our infrastructure. Since Amazon.com runs on AWS, we have to comply with that particular set of requirements. The ISO 27001 certification is particularly useful for our European and Asian customers who focus more on international standards than the SAS 70 or SOC 1 audit, which is something that's more North American in nature here. For those who are interested in federal government use of our services, FISMA is the federal government's process for evaluation of the security sufficiency of networks and systems that's taken on the civilian side of the government. DICAP is the military's version of the same thing. They take a look at our systems, understand where the strengths and weaknesses are, do a series of audits and evaluations, and then either approve or deny access to the systems for that. We're really proud of the fact that the military and civilian government have chosen to use AWS and have found that our standards for security meet, and not only meet, but often exceed what they're looking for themselves. Let's talk about the US-centric SOC 1 Type 2, or North American-centric. There is some Canadian interest in this certification as well. This is an audit more than it is a certification. What this report reflects is that we have an external third-party auditor, in our case Ernst & Young, who comes in and goes through our environment in great detail, does a series of samplings of the way we operate our environment and the controls that we have there, and ensures that we are doing what we say we're doing, and moreover, that we are executing on all the minutiae that are associated with our information security management system. So they come through, they sample everything from, do we have the number of days of video logs that we state we're going to for the cameras that protect our data centers, down to have people signed in properly, and have we recorded their identifying information system when they visit our facilities, on to, do we keep the appropriate numbers of log records for authentication and authorization systems on our network, and do we ensure that those are tamper resistant. So in this case, it gives you great insight into the functional operation of our security controls, and it is something that is available to customers under our NDA. The reason we request an NDA in this is because our control environment exposes a great deal of proprietary information about how we run our infrastructure. So we want to make sure that's not something that's available to our competitors. When we talk about this particular evaluation, the SOC 1 environment, these are the controls that we focus on primarily. Control objective 1, the security organization, is my shop. It's the people who work on security every day in the organization. Do they have well-defined roles? Do we have appropriate numbers of staff to execute the work that we need to in these areas? Do we do an appropriate level of focus on the evaluation of infrastructure before it goes into service, while it's in its service life, and after it's retired over time? The Amazon employee lifecycle, this is a particularly interesting one. It's when a new person is brought into Amazon, how do we manage that person's access to our systems? How do we evaluate whether or not they are trustworthy? And the important thing here is this is something that varies across the world. Amazon is a global company. We have infrastructure all over the planet, and some jurisdictions allow us to do a lot more investigation into the background of our people than others do. So for instance, in the United States, we get full information about whether somebody has had a criminal record, whether that criminal record includes anything that might be detrimental to access to information systems, like were they a hacker in a previous life. That kind of information is not necessarily available overseas. So we do what is the maximum possible under the local law that we operate in each jurisdiction. The life cycle also includes how do we manage employees when they leave the company? So do we turn off their access promptly? Is that turn off of access propagated across all of our systems so that there's no backdoor that they can get in and access customer information or Amazon information after they've left? Logical security is talking about how we control access from our human beings across our network of systems. So for instance, to give you an example of that, if I'm sitting at my desk, I have access to our corporate network. I have to authenticate and authorize my access using the kinds of systems that you're familiar with, things like LDAP and Active Directory for the Microsoft world. But then how do I get from that desktop to a system that contains customer information? There's a series of checks that we have to go through before we permit that access. Is there a business need for that individual to have access to that particular set of customer data, first of all? If there is, they have to be individually authorized to access that customer data. And that authorization is only good for a period of time, 90 days, after which they have to be re-upped. In other words, someone has to, again, positively say this individual needs that access to do their job. Now that they've been authorized for that particular access, the path of access is something that's very carefully controlled. So for instance, going from my desktop to log into an S3 server that contains storage data, I have to pass through a bastion host and a set of firewalls. Let's move on to EC2, the same kind of thing. There's a bastion host that sits between the corporate network and the EC2 network. I authenticate to that using SSH, using a key pair. We don't use passphrases, we don't use usernames and passwords to do that because they're not of sufficient security. So that key pair individually authorizes and identifies me to that bastion host. The bastion host then records a set of information about why I'm there. I have to enter things like change management request numbers or trouble ticket numbers that then identify what I'm doing uniquely, and then I can log into the storage server in question using, again, my unique identifier. No shared passwords, no shared usernames. When I'm on that customer data box, as an example, certain things that I do will generate immediate alarms. So for instance, if I raise my privilege level to something that's equivalent to root on a Linux machine, an immediate ticket's cut alarming to the owner of that host class, that set of machines, saying, someone's now root on this box. Is that okay? So it's a situation that's a series of checks and balances to ensure that our employees are doing precisely what they're supposed to be doing and have limited access to only that which they need for their business. Now, the interesting thing about the Bastion host is it not only authorizes individuals, controls what they have access to, but it also records everything that they do on that network so that we can go back and understand exactly what commands a human being issued and what systems they touched, what they might have done with data while they were on that network, and did they move that data anywhere else. So again, it's a series of controls that allow us very specific access control, very specific audit rights, very specific understanding about what human beings are doing, which is closely associated with secure data handling, the next objective. Secure data handling encompasses not only the logical access to our data and systems, but also the physical contents of those systems. As we all know, hard drives don't last forever. When you have a population of hard drives that's as large as ours, that means there's a fair number of them that are dying at any given point in time. So we have to manage the disposal of those hard drives securely. What does secure disposal mean to us? It means that we degauss every single hard drive when it's reached the end of its useful life or it has failed using an NSA-approved degausser, and then we chip it. So it's down into little tiny pieces. The nice thing there is it's a very easy workflow for a data tech to follow that ensures complete destruction of the data, and somebody can't read our customer's information when it walks out the back door. The second piece of that is the disposal of the machines themselves. There's a decommissioning process that hardware goes through to ensure that we go through and make sure there's no drives left in the machine, that the RAM has been wiped, and then we can remove the machines from service. Physical security, control objective number 5, talks about our buildings, how we control access to the physical perimeter of the buildings. An interesting point here is that in most cases, Amazonians, the employees within the company, have no idea where our data centers are other than generic geographic descriptions. Why? Because they don't need that information to do their job. While security through obscurity is not sufficient in and of itself, it is a useful step in the process of ensuring access control. The smaller the number of human beings who know where the data centers are, the smaller the number of people who could really reveal that information inappropriately. When you get up to one of our data centers, you'll find that there's no big sign on the wall that says, "Here's Amazon, please come in." Instead, they're just generic buildings, nothing terribly exciting. Again, it's about frugality in the company. It's why make it fancy if you don't need to? It doesn't help anybody. The borders of those facilities are designed particularly to channel people through one set of entryways, where they're checked to ensure that they do indeed require and need access to that building. That access has been appropriately authorized. And then we do a series of things that anybody who's been to a major data center would be very familiar with in terms of checking ID and recording who came through the door in a log, and then escorting them while they're in the facility, et cetera. Interesting case in point. I'm the chief security officer for the company. I don't have access to our data centers because I don't need it. It's not part of my job. So if I want to go into one of our data centers, I have to get authorization from somebody whose job it is to maintain that data center. That's true for anybody who's on my team, which is kind of a fun place to be. It's, do we indeed have the controls in place? That's really easy for me to test. I drive by a couple of our data centers on my way to work. Stop in, say hello. Do they ask me, does my badge work at the door? You know, that kind of thing. Environmental safeguards, this is really straightforward. This is, do we keep the temperature, humidity, static levels, et cetera, within our facilities, within the bounds that we define? And we define those bounds to ensure that the equipment operates sufficiently, that we get the life out of it that we need, that we have the durability that's required for our customer data storage. Change management is all about how we ensure that the changes we make to our infrastructure don't cause negative impact to our customers. One thing most people don't notice immediately, but do after a little time, is you'll note there's no maintenance window on AWS. It's because of the way that we operate the infrastructure itself. So in other words, let's say I want to make a change on a piece of infrastructure that supports Amazon EC2. And I'm write my software. I go through a set of regression testing of that software on the Alpha stack, which is really a desktop equivalent machine that I have there. I have a set of tests that I do on it. If it passes that, it can go into beta. Beta means that I have a set of well-defined, well-understood regression tests, unit tests, performance tests that take place. If that passes, it goes into a Gamma stack. Gamma is a replication of the operational environment in miniature. So a few machines instead of thousands and thousands of thousand machines. We do another set of rigorous tests on that. If that passes, we can roll it out onto the fleet. The active fleet rollout process will be familiar to anybody who is dealing with very large fleets themselves. What that means is we roll it out to one box in one availability zone of one region in the world. There's a bake-in period. If it works successfully in that environment, we roll it out to that entire availability zone within one region of the world. If that passes, we then do a rolling region by region, one availability zone at a time, roll out of that software across the company. That allows us to constrain failure to a reasonably small area to get the kind of testing that's required and to ensure that we give the customers that separation of reliability that's necessary for them. Data integrity, availability, and redundancy is closely associated then with the change management process and the environmental. And incident handling is all about if somebody says something's wrong, what do we do? How do we do it? Who do we inform? Over what intervals? What is the SLA associated with notification to our management, for example? And do we have the information at our hands necessary to ensure that we're keeping the records so that we can recreate what happened and understand it? ISO 27001 is the worldwide version of what we talked about under the SOC 1 compliance process. The difference here, beyond its global applicability, is ISO 27001 is significantly more prescriptive than the SOC 1 environment is. SOC 1 is we tell the auditor, here are the controls that we think are important, and here's how we're doing them. The ISO 27001 process says you shall have, and we will go in and validate that you do indeed have those things that we're telling you need to have. So it gives us a balance between things that we want to do to support our business and things that others believe are important to the progress of security in an organization. We talked briefly about physical security already. This is something that anybody who's dealt with large data centers before will appreciate. There are only so many ways to build walls, to build fences, to put up cameras and locks and alarms. The important thing is that we've been doing this for a long time. We've got a really good handle on this. This is something that we believe very strongly in at the company. If you think about it, for us, this is the foundational element of our entire face of our company. We don't have a store that you can walk into and touch something and interact with an employee. Our entire existence is logical. It's online. So we really have to make sure that we do this right. Because otherwise, you're not going to have the smiley face at the end of the interaction with us that we really want you to have. Briefly, a quick look at where we are around the world. We divide ourselves up into regions and availability zones, and I'll talk about that here in a sec. The gold boxes on the screen, just to refresh your memory, are the areas where we have all of our services available, so S3, EC2, et cetera. The round red dots are CloudFront, our CDN locations around the planet. The important thing here is that we give customers a set of different geographies to choose from, not only for the performance reasons that you're probably used to, but also for the regulatory and control reasons that may be particularly applicable to your environment. So we have a number of customers, the United States government, as an example, who say, I want you to guarantee that my data is going to stay within the United States. We have a US region. We don't move your data outside that region. You're the one who has to make the decision to doing that. The same thing is true for all our regions around the world. The customer has to make a decision to move data out of it. We don't do any global load balancing, as an example. Within each region, there are availability zones. Availability zones represent a containment failure area for customers, so they can choose to use multiple availability zones to ensure they have the reliability, the availability of their data that is necessary for their work. That's important to the security world because it gives us the ability to separate, if you think of the CIA, triad, confidentiality, integrity, and availability of data, this is the A part of that particular phrase. How do you architect your environment? A different topic, something else that goes on during the Solutions Architect talk series, but it also is relevant to our discussion here today. We've talked a little bit about human beings and access, and we talked about the Amazonians who operate the infrastructure. But we also have tools that are available to help you replicate your workflow and your operational environment from a security perspective. Identity and access management gives you the tools necessary so that you can assign rights and responsibilities to your employees consistent with their job. So the example we've got on the screen right here, a set of admins, developers, and some test folks, you may want to assign rights to different groups so that they can do different things. So for instance, the administrators may be able to do everything using your resources. The developers may be able to interact only with their virtual machines or their objects that are in the storage system. And the test folks can go ahead and read any of it, but they may not be able to delete things in S3, as an example. So if you think about the functional decomposition of your work, your operating environment, you can then segment those people into groups of responsibility and give them individually the accesses that they need to do their job. And that's something that we believe is a very, very important basis for operating securely in any environment, whether it's the cloud or otherwise, is minimization of access, and ensuring that people have adequate control over them as an individual human. That means I can identify precisely who did this, as opposed to sharing one account amongst many people. The bottom bullet on here talks a little bit about MFA devices. MFA is using a hardware one-time token generator, or we now have a software version of the same thing that can run on your smartphone. But it adds a layer of security to your interactions with AWS that's of significant value, and a reason that I wanted to bring it up here right now. If you think about the way that you can control access to elements within the AWS portal, things that are really important, like your secret key, your access ID, etc. Some folks have chosen to add another layer of authorization or acknowledgement on top of that, and that's that MFA token there. It's the kind of thing where it may be applicable both from a security perspective. You have that one piece of hardware that nobody walks out with, therefore they can't walk off with your identity and can't interact with your AWS assets. Furthermore, there's a significant regulatory component that's associated with that. In some very highly regulated industries, records have to be kept for a defined period of time. Using S3 versioning and MFA, you can ensure that people can write to the record repository, any of your employees can, for instance, but the only person who can delete from that records repository is a records control officer, and they have to have that physical hardware token in their hand, which prevents oopsies or accidents. There has to be a positive action to do that. So it's got both a security component and a regulatory component for those who have that particular need. Talk a little bit about EC2 itself. We often get questions about this. It is our largest service, obviously. We divide the world of EC2 into two pieces, the host operating system and the guest operating system. The host operating system is the bit of code that runs at the bottom of the pile, that sits on the physical iron itself, and it's the part that our employees interact with. The important thing here from a security perspective is every individual uses individual SSH keys to log in. We don't share accounts with any of our staff via the Bastion host that we talk about already, and their accesses are logged and audited. And the and audited part, I think, is critically important. It is wonderful to collect logs about who did what, when, where, how, etc., but if you don't go back and look at them, what's the point of collecting them in the first place? Picking up after a mess? No. Identify the problems before they become major issues. You do that through an audit process. Guest operating system, this is something that's controlled by the customer at the root level. The second sub-bullet there is critically important. You control the keys to the administrative rights on that system. We don't. That sometimes results in entertaining conversations with the customer service staff, where a customer calls up and says, hey, I'm having a problem with my instance. Can you please log into it and look at it for me? And the answer is, well, no, sorry. We don't have rights to that. You can create an account and specifically authorize us to have rights to that box, but we don't by default. In fact, our best practice documents suggest that as soon as you log into an instance for the first time, you regenerate the key pair or administrator passwords associated in a Windows box, for example, so that the ones that we generated on fresh boot are no longer useful on the machine. That way you ensure that we don't have any records of the access credentials necessary for administrative rights on that machine. Every EC2 instance comes with a firewall. We require it. It's a mandatory inbound instance firewall that is in default deny. Default deny means that when you start that instance up, you have to tell us what ports to open up, and we don't open them until you do that using either your X509 certificate or your secret key to authenticate yourself. There are outbound instance firewalls available in virtual private cloud. An important differentiation in what we call EC2 Classic internally, the mandatory inbound firewall is stateless, but in VPC, the inbound and outbound firewalls are stateful. So if you care about the difference between stateful and stateless, take a look at VPC. VPC also offers some ability to restrict traffic within subnets on the network using access control lists. We quite often get questions about instance isolation, meaning can one customer talk directly to another customer without passing through the firewall? This gives you a graphical depiction of the traffic path. So if one customer is trying to send data to another customer on the same physical box, it's important to note that it must pass through the firewall layer prior to going to that other customer's instance, so we can enforce the restrictions that they put on inbound traffic. The other piece of that that's very important is the firewall layer we're talking about resides outside the customer's operating system. Two benefits to that. One, they can't tamper with it and cause traffic to go places that they don't expect on the other side. The second is it allows a point of two-person control for those businesses that are highly regulated or choose to do so. Two-person control means, let's say that you happen to be the administrator on a virtual machine, and you have full administrative rights to that, which means that if it just is using a firewall that's resident in the host operating system, you can change that, the guest operating system, pardon me. You can change the rules associated with it. However, the firewall that's enforced at the hypervisor layer can only be changed using a set of credentials held with AWS. So some places have chosen to bifurcate that responsibility. You may have admin rights on the virtual machine at the OS layer, but he may be in the security group and be the only one who's got rights to change the firewall rules themselves. That does two things. It prevents a lot of mistakes, and it allows people a measure of assurance that one person can't cause them a great deal of damage or harm. So something to look at. Virtual memory and local disk, we talked about disk destruction already. There is a disk management layer that sits between the virtual drives that we expose to EC2 customers and the physical hardware underneath. That allows us to have one customer use a machine. When they leave, the next customer that comes on does not have access to the first customer's data. That's something you can test. It's very straightforward. Create an EC2 instance, take a look at the raw device that contains the blocks that you're going to use to boot up your virtual machine. You will find that you can't read anything other than zeros, because that's a layer that we put in place to ensure that we don't have cross-customer contamination. As part of our best practices, we encourage you to encrypt your data, whether your data is in S3 or in EC2. We provide a series of libraries for S3 that allow you to encrypt the data there, either on your own premise, in your EC2 instance, or you can use our server-side encryption option in S3. Why is that beneficial? Two reasons. One is it gives you a level of assurance that if somebody gets a hold of that physical disk, they're only going to get gobbledygook because it's still encrypted. The other piece is when you shut down those virtual machines, you know that your data, when it's at rest on our network, is encrypted. So that if you control the boot keys yourself, for instance, either directly using Windows BitLocker or one of our customers, as an example, Trend Micro and so forth, have a series of encryption modules that are available that you can use to encrypt the data sitting on your virtual machines. Network security is always a fun topic to talk about, and this is a great one for questions afterwards, actually. But to distributed denial of service attacks, well, denial of service attacks in general, whether distributed or not, are always a major question that we run into with customers. There's something we have a great deal of experience with, for better or for worse. So it's something we have a great mitigation path for dealing with. One of the sort of fundamental pieces here is ensure that we've got the ability to direct the traffic on our network where it needs to be and keep it off the pieces that it doesn't need to be on. Man-in-the-middle attacks, we strongly encourage you to interact with our API endpoints using SSL. It is a fundamental layer of protection for you and for us. It's something that we give every individual access to without additional charge. Please use it. We do have unencrypted API endpoints available. Those are necessarily used for public access to unencrypted information, but please, if you're dealing with API calls to us, use the SSL endpoint. IP spoofing, all that's going to do is cause alarms to go off on the security team if you try and spoof outbound packets from addresses that you don't control. It's not going to be successful. Port scanning, there are a series of automated controls that we have that identify certain types of malicious behavior on our network. So for instance, if you're going to start scanning for vulnerable SIP phones as a case in point, we detect that automatically, we quiesce it automatically, and then we get in touch with you and say, why are you being annoying? That is not something that's appropriate. Packet sniffing, promiscuous mode doesn't work. Go ahead and put your virtual machine's NIC into promiscuous mode. You only get packets handed to you that are intended to be in your hands. We talked a little bit before about virtual private cloud. VPC is something that's near and dear to my heart. Before I became the Chief Information Security Officer, I owned the team that built VPC, and it is something that I think is a really useful tool for many of our customers out there. It allows you to do something as prosaic but complicated as, I want to get rid of this data center that I have, but I don't want to get rid of the tools that I use to manage the data center currently. I really like the environment that I have right now for access control and patching, etc. VPC allows you to take that logical environment down to the individual IP addresses that you've assigned to machines and move it into the cloud. It carves off a piece of our infrastructure and allows you to assign individual subnets, to launch machines into subnets, then to create individual firewall rules for the subnets or those virtual machines. This slide builds rather slowly. There we go. And then define the pathway that your traffic gets to and from that virtual private cloud. The important thing about that pathway is there are several options that are available. You can go directly to the internet, out from a VPC. You can go over an IPsec tunnel that you can set up using many brands of internet standard security appliances automatically. You don't have to call us, you don't have to talk to us. You can make an API call to set up a VPN tunnel with us. For customers who have very high bandwidth requirements or customers who require control over latency or jitter of their traffic, we offer Direct Connect, which is a way for you to provision a circuit directly to us at one of our handoff points, and then you have access to your VPC from there. What does it look like from a logical perspective? The security controls will look really familiar to you if you're running a data center right now. On your instances, they've got security group controls in and out, the firewalls that we talked about previously. You've got subnet level network ACLs that allow you to say the application servers can only talk to the databases on the back end and the web servers can only talk to the application servers, and give you the layered control that's either something you're used to right now or that you find necessary to meet requirements for regulations. So for instance, PCI DSS requires that kind of separation of network traffic and responsibility amongst different machines. Some customers ask us about the physical boxes themselves. You know, I really love VPC, but I want to make sure that I'm the only tenant on that physical piece of hardware that you have, because I don't want to be worried about anybody else on that machine. I understand that you keep customers separate, etc., but this is important to me. Okay, we give you that option as well. VPC dedicated instances. It's something where you can say that I want this whole box to myself, and we say no problem. It's yours. You can use an API call to do it. You don't have to make a phone call to a sales rep or something like that. You can, as the last bullet states, make an entire VPC dedicated. This allows customers who want to ensure that there is no way that anybody else can be co-resident with any of their machines, no matter where they're placed, can do so. The last bit that I wanted to bring up is, quite often we get a lot of questions about, all right, you've talked about all these different things and you've got different regions around the world, and I noticed that you've got a commercial region and you get this VPC, and then you've got a US GovCloud region. Okay, what's the difference between them in the security operations and the security layout? What you see on the screen is the only difference. We don't reduce the security level of the commercial cloud as compared to the government infrastructure. We apply the same rules, the same regulations across the board, with the exception that the US GovCloud region has logical access and physical access only by US persons. So it means that the difference there is the humans. Otherwise, all of the logical access controls are identical, the same. And that is the end of the prepared presentation, and I'd love to hear some questions from folks. We've got about 8 minutes left, so ask away. I think we have some, yes, we do have mics right here.
Well, I was just curious, if I put my infrastructure in yours, how do I do pen testing?
I'm sorry, what have we been doing?
Penetration testing.
Yes. As part of our, there are two levels of, well, there's several levels of penetration testing. Penetration testing is something that takes place on a regular basis by a series of different individuals. The first is my internal team. We have a continuous penetration testing go on. We don't do something on an interval by interval basis. We actually run it continuously across our fleet. The second level is by our internal audit team. They do their own penetration testing of our network as part of our internal insurance process. The third part is external auditors do penetration testing as part of our SOC 1 compliance program, our ISO 27001 compliance program, and our PCI DSS program. So we have a whole series of different people doing penetration tests at the same time. Now the nice thing is customers can do their own, of their own environment. So if you're running a set of machines on our environment, you're welcome to penetration test those. Off of the Security Center website that you see right on here, there's a link that you can follow that says request penetration testing on my machines. We ask that you fill that form out so that we can ensure two things. One is we don't allow penetration testing of micros or smalls because of the concern about affecting your co-resident tenants on that machine, just from a traffic perspective, not from a security perspective. And the second is because we don't allow denial of service attacks on the infrastructure, because that causes alarms to go off and other unfortunate reactions where we end up calling the FBI or something like that on you. So we ask you to work with us ahead of time, but you're perfectly willing to test your own stuff. Sir.
Hi. Do you plan to undergo SSIE 16 SOC 2 audits?
I'm sorry, I have a hard time hearing you.
Do you plan to undergo SOC 2 in addition to SOC 1?
SOC 2 is something we're considering. What about SOC 2 is particularly interesting to you?
I guess it's more prescribed to CISTARS criteria. It's similar to 27001 versus having the flexibility to define.
Yeah, do you think that there's enough difference from 27001 where it's a useful thing to do, or is 27001 sufficient?
It depends on the use case.
Okay. I'd be interested if there are use cases that you think the 27001 is not sufficient. That'd be a great conversation to have.
Thank you.
Okay, thanks.
Hi, can you talk a little more about what you do for PCI DSSI compliancy, DSS?
Sure. For PCI DSS compliance, what we are is a PCI DSS level 1 compliant infrastructure. Notice I didn't say certified. Certification can only be achieved from top to bottom of the stack. So if you look at the PCI DSS rules, we are what's called a compliant service provider, which means that your QSA can rely on the statement from our QSA for a series of controls. You know, we talked in the beginning about the responsibility between the customer and AWS and security. The same thing is true within PCI DSS. So your QSA is going to ask a lot of questions about physical security and network security and separation, those sorts of things. They can answer those questions using the report from our QSA. When they get to the level of things like the configuration of your databases and your maintenance of usernames and passwords and your use of encryption to your customers, that they will have to validate for themselves on your infrastructure because that's something you control. So it's a combination effort. We provide you the answers to a whole set of questions to begin with, and then you have to fill in the little piece above that that represents that which is unique to your environment.
I had a question about the distributed denial of service attack protection. It seemed like it's there, and I wanted to know up to what layer you go.
It is there, and it is something that we can invoke when appropriate. For those customers who have a premium support relationship with us, you can file tickets if you believe that you're under denial of service attack, and then we'll take appropriate action to ensure that we work with you to stop that. We often get asked why it is that you don't just proactively block inbound denial of service attacks. One really important reason, we don't know ahead of time what's legitimate traffic and what's not. The canonical example of that was after Michael Jackson passed away, we saw a very large spike in inbound traffic to one of our customers, which we said, this is interesting. Are they being attacked? What's going on? When we investigated, we found out that that customer was Sony. They had put their Michael Jackson tribute site on AWS and hasn't told us. That's great, they can do that. It's an easy thing for them to do. If we had shut that off, we would have stopped perfectly legitimate traffic from entering the network, as opposed to blocking something that was by definition inappropriate. So the only way we can identify whether traffic is legitimate or not is when we work with the customer to understand what they expect to be seeing. The customer needs to be able to monitor their own environment to understand what it's doing. You know, you can use CloudWatch to do that. You should have a set of tools in place to look at the security of your environment. There are lots of SEIM vendors out there who have useful products that will ingest logs produced by us, produced by your systems. And then you can understand what you're seeing, work with us then to mitigate attacks that are coming inbound. Okay?
What sort of support or best practices documents may be available to extend, obviously, the good work that you've done to protect the systems into architecting customers' applications?
That website right there, scroll down to the bottom of it, the last 2, I believe, paragraphs contain links to best practice documents, which explain if you're architecting things in EC2 or S3 or SDB or DynamoDB, exactly how you should set up your environment.
Especially, I suppose, in situations where you're migrating existing security and entitlement systems, considering migrating it over to the cloud.
Yeah, if you're moving from an existing on-premise environment where you're doing authentication or authorization work, there's a particularly interesting document from our identity team that talks about ID Service Federation. And it talks about how to do that in an LDAP environment, but it also will explain how to run ADFS if you're using Microsoft AD on your current premise, so you can link that directly into AWS.
Thank you.
Hi, this is a two-part question, but they're real simple, hopefully. Earlier in one of your slides, you talked about the DICAP MAC3 sensitive IATO. When do you guys envision getting the full authority to operate?
I'd love to be able to answer that question. The reason I smile is because, unfortunately, those are usually out of our control. I believe that particular one we actually have now. Bill, do we have the ATO on? We do. Okay, there you go. There's the answer. The slide is old, and these things are fluid. So yes, it's issued. If you'd like to follow up with that guy right there, give you the answer you needed.
Perfect. And I take it that's on the Gov Cloud, the US Gov Cloud?
No, that is on the commercial cloud. Like I said, the separation controls are exactly the same across the entire fleet. The only difference is US persons only.
Thanks.
Sure.
If I was about to leave an organization, on your type 2 control objectives 1 to 9, what level of security would it be considered if I came in with, say, a flash drive and tried to download some of the documents that I had created in the firm?
Okay, so you're an employee of Amazon and you're going to leave
Amazon or any other company.
Okay, sure.
What,
Talking generically about that, it depends entirely on the individual system that you're accessing. Some systems are designed to be very high assurance and very high security. So if you look within the Amazon environment, for instance, there are areas of the company where the systems are so critically important to the privacy of our customers and their data that the USB ports are disabled. Or they're caulked shut, literally, in some systems. And you're not allowed to bring a flash drive into the room where those machines are. The other part is there are parts of companies, Amazon included, that are wide open, that are intended for public access, in which case that's perfectly reasonable. So it really is something that can't be answered with a 1 or a 0. It's got to be specifically dependent on the individual in question and where they're working and what they're doing.
So what about like Word documents or something like that?
Again, that depends.
That depends.
Yeah, it depends. Some things...
So you couldn't categorize it in your 1 to 9 scenario?
The 1 to 9 are categories that permit us to identify controls that an auditor can test specifically. So, you know, this is the physical access control, meaning is there an alarm contact on that door and does it function properly when the door is opened? Or is this virtual access control in place so that when he logs onto that system, a record is created, it is cryptographically signed and moved to a record retention system so that we know that he was there and it's non-reputable.
Okay.
Okay?
Thank you.
Sure. Ma'am.
Sure. Do you guys plan to participate in Cloud Security Alliance Star Registry, and if so, when?
We are participants in CSA, and in fact, we just started sponsoring some CSA work, so you'll see us in more of the CSA discussion for currently.
Okay, so follow-up question, is that okay?
Pardon me?
I have a question.
I'm getting the big red zeros, so why don't we continue the conversation outside?
Sure.
All right? Thanks.